An amine is a hydrocarbon that contains an amine functional group. This is the first family where the name of the family and the name of the functional group are the same. This sometimes creates confusion. Remember, an amine functional group is a nitrogen attached onto your molecule. You would either see an NH2, an NH, or an N. So they have the general formula R, representing your parent chain, N, and R prime 2. The R prime 2 could either be carbon chains or hydrogens, depending on what classification of amine you have. Amines are classified based on how many alkyl groups are attached to the nitrogen. A primary amine has the nitrogen only attached to one carbon, which means you would see NH2 at the end of a chain. Secondary amines have the nitrogen attached to two alkyl groups, or two carbons, so you would see N included in the chain. And finally, a tertiary amine has the nitrogen attached to three carbons, which means the nitrogen will not be attached to any H's. You have to be careful. The definition, or the way we classify primary, secondary, and tertiary amines is different than how we classify primary, secondary, and tertiary alcohols. Naming an amine. The longest alkyl group attached to the nitrogen will be your main chain. You drop the E of the parent name and use the suffix amine. You use a position number if there's more than one possible place for the nitrogen to be attached to the parent. The nitrogen takes number priority over other alkyl groups, but not double or triple bonds. Name any other alkyl groups attached to the parent chain as the prefix. And finally, name any other carbon alkyl groups attached to the nitrogen using N as the position number. Place these groups in front of the prefix. Here are some examples. In example A, I have a primary amine because my nitrogen is only attached to one carbon. My main chain will be the two carbons, giving me the root eth. Because they are single bonded, I would use ane as my suffix. I will drop the E and use a position number to tell where the nitrogen is, and I use the second suffix amine. The final name for molecule A is ethan-1-amine. For molecule B, my parent chain is the longest consecutive row of carbons connected to the nitrogen. 3 carbons gives me the root prop. Because they are all single bonded, I would use ane, but I would drop the E. To indicate where the nitrogen is, I would number my main chain so it gets the lowest number. It is on carbon number 2. I indicate it's an amine by using the suffix amine. I have last to describe the carbon attached to the nitrogen. Because it's a one carbon, it is a methyl group, and its location is attached to the nitrogen, so I use the position N. The final name for molecule B is N-methylpropan-2-amine. Pause the video now and name molecule C. Here is the answer for our molecule C. The longest consecutive chain attached to the nitrogen is the 4 carbons going horizontal across the page. That gives me the root bute. Because they are single bonded, I would use the suffix -ane, but I would drop the E to indicate that there's an amine attached. In order to number my chain so that the amine gets the lowest possible position, I would do it in this manner. This gives me an amine on carbon number 2. I finish off the name for the parent chain by writing the prefix describing the methyl. Now, I would name the 2 carbon chains attached to the nitrogen using N as the position number. These always go out in front of the name and do not follow alphabetical order with other alkyl groups attached to the main chain. I have 2 carbon chains, so those will be ethyl groups. Because I have 2 of them, I include the prefix di, and I would indicate that they are both attached to the nitrogen. The final name for molecule C is NN-diethyl 3-methyl butan 2-amine. Properties of amines. There is a wide range in amine melting points based on what classification your molecule is. If it is a primary amine, it can make 2 hydrogen bonds. If it's secondary, it can make 1 hydrogen bond. And if it's a tertiary amine, it can only dipole-dipole. Remember, accepting hydrogen bonds only affects the solubility of a compound. All of these 3 intermolecular force combinations gives amines a higher melting point than alkanes. In terms of solubility, you also see a range depending on what classification you have. If you have a primary, it means you can make 2 hydrogen bonds. If it's secondary, you can make 1 and accept 1. If it's a tertiary amine, then you can only accept 1 hydrogen bond. All 3 intermolecular forces increases the solubility compared to an alkane. Other characteristics of amines. They all have a distinctive fishy odor. Fresh fish doesn't actually smell. The fish smell is created by the proteins in the fish muscle being broken down by bacteria to create amines. Amines also act as weak Bronston-Lowry bases, just like ammonia does. The lone pair of electrons on the nitrogen can accept an H+ from an acid. Because of this, cooks often use citrus or vinegar in fish recipes to pass off old fish as being fresh, because the lemon in the acid will neutralize the amines and remove the fishy smell.